Good day, students. I am now going to discuss to you the answer for the group work that you've done about bathtub water level control system. So once more, this is about analysis and design of control systems. Let's review the problem. Your bathtub at home is a control system that keeps the water level constant. A constant flow from the top yields a constant water level. Because the flow rate through the drain increases as the water level increases and decreases as the water level decreases. After equilibrium has been reached, the level can be controlled by controlling the input flow rate. A low input flow rate yields a lower level, while a higher input flow rate yields a higher level. Sketch a schematic control system that uses this principle to precisely control the fluid level in a tank. Show the intake and drain valves, the tub, any sensors and transducers, and the interconnection of all components. Draw a functional block diagram of the system, identifying the input and output signals of each block. Analysis of the system concept. So we're going to make some assumptions. This assumption is not mentioned in the problem, but it is better to have these assumptions that will not affect the requirement of the system and the concept of the system. So first, the input pressure of supply water is constant, or else the constant water level or equilibrium point will never be achieved. The system has a start and stop function so that it could be turned on or off at any point of its operation. At off state, both the fill valve and drain valves are closed, meaning no water flow in both valves. The initial level of water could be at any point. Other outside factors or disturbances are omitted for design purposes. In other words, all devices are in good condition, working condition, and in the right specifications. So, yung pressure ng supply water natin, yung nanggagaling sa gripo, we will assume that to be constant, no? Actually, in reality, hindi naman talaga constant yun, no? It's varying at hindi natin na malalaman kung kailan biglang lumalakas ang pressure at biglang humihina. Okay, but for design purposes, we need to assume it. Okay? Or else, magiging continuously oscillating ang ating system at wala tayong makukuhang control. At of course, lahat naman ng system ay may start at may stop. Okay, I remember no when your first activity, first homework na ginawa ninyo noon, first assignment na ginawa ninyo, you many of you or some of you considered the start button, no, the pressing of the power supply, the start, as the input signal. No, I want to correct that. Pressing the start button or turning on the system is not actually providing an input signal to the system. Magkaiba yun. Okay? At pwede tayong mag-start or mag-stop anytime. Okay? Now, at off state, ibig sabihin naka-stop, both the fill valve and drain valves are closed. So, naka-close siya. No? Sarado yung valve. No? Walang dumadaloy na tubig. At ang initial level ng water ay at any point, no? So meaning to say kung saan mo siya huling by the time you turned off, kung saan huling level ng water ay dun lang nananatili. Okay? Unless may manual override na ginawa para i-drain totally yung water. So the basic concept, again, let's analyze, no? The basic concept, no? The things that are not directly, no, stated in the concept. So constant water level could be achieved once the output flow rate equals the input flow rate. No? Yun yung gustong mangyari, yun yung requirement na magiging constant ang water level, hindi na umaangat, hindi na bumababa by the time na nag-equal na ang flow rate sa output or sa drain at saka sa input or sa supply water. The lower the water level yields decreased output flow rate. Okay? Kung ang water level is mababa na, magbibigay ito ng mababa rin, no, na output flow rate. At kapag ang water level mataas na, magbibigay din ito ng mataas na output flow rate. Okay? Ang input flow rate ay maa-adjust lamang kapag ang water level ay equilibrium na. Ibig sabihin, nag-constant na siya ang water level. Yun lang yung time na pwede na nating i-adjust yung input flow rate. Kasi sa concept kanina nabanggit na ang input flow rate ay constant, no, or hindi nagbabago. Okay? Increasing input flow rate would mean more water supply input and yields higher water level, while decreasing input flow rate would mean less water supply input and yields lower water level. Note that both filling and draining of water never stops unless the whole system is turned off or there are outside factors or disturbances. Di ba hindi naman nabanggit doon sa ating problem na may point na hihinto, no, ang fill valve or yung drain valve. Okay? Hindi siya nabanggit. So continuously ano lang siya, no, continuously flowing, bumabagal, humihina, or bumibilis lang ang mga flow rate ng parehong input at parehong output flow rate, pero hindi nabanggit na siya ay totally nag-stop. So, yung assumption natin kanina, kapag nag-press tayo ng stop, inassume natin na mag-i-stop ang pag-fill at ang pag-drain. So, hanggat hindi natin ini-stop, hanggat patuloy siyang nag-start tayo at patuloy siyang nag-ooperate, so it's understood, no, na continuously filling and draining. So that was the analysis of the concept. Now let's go to the system design specifications. Paano na natin ngayon i-design ang ating system ayon sa mga specifications. Actually, meron tayong tatlong requirement, no? Yung una, varying output flow rate. So, di ba, nabanggit nga na habang nagbabago ang level ng water, magbabago rin yung output flow rate ayon sa height ng water level. No? Nabanggit natin kanina yon. So, if that is the case, ano ang kakailanganin natin na devices? So, we need to sense, no? We need to detect yung level ng water. Kaya kakailanganan natin yung water level sensor. At kapag na-detect na natin ang water level, ano naman ang kakailanganin nating device? Okay, para makontrol ang flow rate nga sa output. So, kailangan natin ng drain valve, no? Proportional control na drain valve. Okay? Now, ang isa pa nating requirement ay yung water level na ito ay maging equilibrium or it will reach a constant water level. Okay. So, ano ba ang triggering factor na patuloy mag-ooperate yung controlling? Okay? Ito yung triggering factor niya na hanggat unequal ang input at output flow rate, patuloy pang magkukontrol ang ating system hanggat ma-reach niya ang equilibrium, hanggat mag-equal na ang flow rate ng dalawa. So para ma-achieve yan, ano ang kailangan nating device? So kailangan natin ng flow rate sensors both sa inlet water at saka sa outlet water. Okay? So kapag na-sense na natin, no, na nadidetect na natin kung ano yung flow rate ng bawat isa, okay? Anong gagawin naman natin? Anong sunod nating gagawin? Okay? So, kakailanganin natin ng isang relay switch, an electronic switch, para ipang-activate ang ating fill valve. Kasi di ba sa requirement kanina, nabanggit na we could vary the input flow rate to vary the water level kapag equilibrium na. Okay? Kaya ang actuating device natin dito is a relay, or that is an electronic switch. At yung last requirement sa ating system is to control or adjust the desired water level. Okay? Ang kanina kasi, yung constant water level na ma-achieve, hindi pa yun yung desired water level ng gagamit, no, ng bathtub. Okay? Kumbaga yun lang yung initialization ng pag-open, no, ng system. Okay? So, ma-adjust lamang natin, no, ng gagamit, no, ng bathtub kapag nag-equilibrium na. Pero syempre, kailangan may chance pa rin na ma-set niya sa desired water level niya. So, ano ang triggering factor? Okay, kailangan ma-achieve muna yung equilibrium. Okay? At kapag naka-equilibrium na ang water level, magbibigay na ng water level reference or settings. Kung ano yung gustong setting, yung medyo low level lang or bahagyang halfway ng bathtub or kailangan puno yung bathtub. Okay? And then, another triggering factor is the actual water level in the tub. Okay? So, ano ba yung actual water level? Kasi kanina, nung nag-constant ang water level, hindi naman talaga alam ng user, no? Kung ano yung actual water level. Maaring yung system alam niya na kasi may sensor na siya. Pero kung ano man ito, yun yung starting point ng system natin. Okay? So, ano yung mga sensing device? Okay, dun sa equilibrium, na-achieve na yun dito, no, sa second requirement natin once okay na yung controlling dito. So, na-achieve na ito. Okay? Yung sa number 2, we need the potentiometer. Okay? And then, for the actual water level, kung yun ay na-reach na yung desired, so kailangan natin ng water level sensor. So ano yung mga actuating device kakailanganin? So yung fill valve, syempre, yung drain valve pa din, at yung relay. Okay? Now, we need to identify the specifications of each controller, input and output devices, and even the process. Here, I provided you the types of the devices only. No? For simplicity of discussion, hindi na natin muna sa ngayon isinama yung specific na capacity or specifications, no? Device specifications neto. So for now, in-identify lang natin na ang ating flow rate, kailangan ng flow rate sensor, kailangan ng water level sensor. So this is an ultrasonic, okay? Kasi proportional control tayo. Ibig sabihin ng proportional control, ito ay every point in proportion, no? Every point, every level ng height ng water. Okay? Hindi siya stepping up na, for example, from 10 cm, biglang nag 20 cm, biglang nag 30 cm, hindi, no? Kundi all continuous count, no, of the water level. And of course, we have the potentiometer. We may use the PLC of programmable logic controller for our controller, or we may use microcontroller. But if you're going to use the controller, you still need a relay. Okay, but if you're using a PLC, you don't need a relay because inside the PLC are a combination of thousands of relays already. Now, it has a relay function inside. And we need a proportional valve and, of course, the bathtub for our process. Okay? So, yung specifications, yung detailed specifications na sinasabi ko, for example, anong klaseng, ano yung capacity, for example, itong ultrasonic sensor, gaano yung layo ang kaya niyang i-sense, hanggang 5 meters lang ba, hanggang 20 meters ba, no? Kaya niya bang i-sense, or baka hanggang 1 meter lang ang kaya niya. No? Yung ganung mga capacity. Okay? Sa flow rate, anong volume ng water ang kaya niyang ma-accommodate, no? At a certain given time, no? Sa PLC, ilang input-output ang kakailanganin natin. So, meron ditong analog input kasi may mga PLC na walang analog input, no? By the way, PLC are digital devices, kagaya ng microcontroller. They are digital devices. Ibig sabihin, they operate in binary signals, high and low, 0 volts, 5 volts. So, digital yon. Pero when you are controlling a water level, it's an analog signal, no? Continuous, proportional. So, yun, no? Yun yung mga specification. So, ilang input, output terminals meron ng isang PLC? Ilan ba ang kakailanganin mo? Depende yan sa mga, kung ilan ang input devices at ilan ang output devices mo. Okay? So, mga ganon, no? Sa proportional valve, so, ganon din, no? Ano yung volume, flow rate, volume, no? Na kaya niya. Okay? Kumbaga, parang yung sa diameter, no, 'di ba? Alam naman natin yung tubo, mas malaki ang diameter ng tubo, mas malaki ang volume flow rate na kakayanin niyang padaluyin sa kanya. Pag maliit ang diameter ng tubo, maliit lang din ang maximum volume flow rate. Mga ganun, no? Ang mga specifications. But for now, we really don't need to identify those things. Kakailanganin mo nga ma-identify ang ganun kapag ikaw ay gagawa na talaga ng project, okay? Ng thesis mo, no? So kailangan mong alamin na 'yon. Okay, so let's now proceed to the first system requirement, no? Outlet water flow rate control. So in this diagram, here is our bathtub, here is our controller, okay? So the bathtub is the process, we have here the controller, and we have here the drain valve as the output device, and we have here the ultrasonic sensor, okay, as the input device. Now, the orange color here is a signal of sound, no? Ultrasonic, ultrasound, ultrasonic, no? So it emits sound. When it strikes the water, it bounces back. So the sensor could determine the distance, no? It converts into electrical signal and feed it to the PLC, okay? And then the PLC will provide electrical signal to your valve so that the valve will open or will close depending on the level of the water. Sabi nga natin kanina, ang requirement is kapag mababa ang level, mababa lang din ang flow rate na lalabas. Kung mataas ang water level, mataas din. Okay? Notice na wala tayong connection. Ito yung input valve, inlet valve, pero wala tayong connection sa PLC because for now, for output flow rate control, hindi siya kasama sa controlling ng system. So, yung scenario, constant, no? Ang flow rate mula sa inlet. Okay? So, by the time may water supply na, okay, magkakaroon na ng water level dito. Ganito palang kababa kunwari. So, dahil mababa pa yung water level, mabagal lang din yung flow rate. No? Yun yung concept kanina. Habang tumataas ito, nadadagdagan din yung flow rate. Okay? Ayan. Patuloy na tumataas yung level ng water, tumataas din yung flow rate. Ngayon, ang isang system, wala namang perfect na system, no, na kapag na-reach niya yan, wala nang chance na umangat. Most probably, aangat pa yan. Okay? Kahit na nag-equal na kanina yung flow rate ng input at saka ng output. So, sabi nga kanina, kapag mataas ang flow rate, mataas ang water level, may tendency mataas ang flow rate dito. Okay, in-indicate ko siya ng mas maraming parang lumalabas na water. Okay? Now, please take note that when the valve is 80% to 100% open, yung talagang bukas na bukas, yung gripo, kumbaga, parang ganyan, it yields higher flow rate. At kapag ang valve naman ay 10% to 20% open lang, bahagyang nakasara siya, it yields slower flow rate. No? Now, as we've mentioned earlier, by the time that the water level increased, the tendency mabilis din, no? Ibalik ko lang, no? Okay. Yan, this one, no? Kapag ganito nakataas ang water level, then mabilis din yung flow rate sa pagde-drain. Kapag mabilis ang pagde-drain, syempre, ang tendency, ang water level ay bababa. Okay? Ayan. So, kapag bumaba na ang water level, sumusunod din yung flow rate, bumababa din. Ngayon, patuloy itong tataas, bababa, tataas. Kailan nga uli ito hihinto? Sabi natin kanina, ano ang nakasabi sa requirement? Hihinto lang siya kapag dumating sa point na ang flow rate dito sa inlet source, no, ay equal sa flow rate sa drain. Okay? Uulitin ko lang, no, maganda ang performance ng system mo, very accurate yung system mo kung hindi na siya nag-oscillate taas, baba, taas, baba. No, very good yun. But isipin natin, tandaan natin na hindi lahat ng system is ganun agad. No? Let's always anticipate for oscillation bago siya mag-steady state. Okay? So, additional information, no? Please note that in physics, the deeper the water, the higher the pressure at the bottom. Thus, it yields higher flow rate. Meaning to say, kahit na wala pa tayo ditong valve, okay, di ba kanina ang valve nag-open, nag-close para ang flow rate na lumalabas na yung tubig na lumalabas ay nakokontrol natin. Pero ganun pa man, kung wala tayo ditong drain valve, yung just because of the principle of physics, yung volume flow rate na lumalabas na water ay sadya talagang i-increase or di-decrease depende talaga sa water ng level, no? Because of the principle of physics. Kahit wala pa tayong valve, sadyang ganun ang mangyayari. Okay? So, you might ask, ma'am, bakit pa ba kailangan ng valve? Ganun pala rin naman ang mangyayari. No? Kusa naman palang babagal yung flow rate, decreasing flow rate kapag mahababa ang water level, at sadyang higher flow rate kung mataas naman talaga yung water level. Ganun naman pala talaga ang mangyayari. So, bakit palalagyan ng drain valve? Okay? So, the answer is, we have control. We need to have control sa ating system. Kung hindi natin dito lalagyan, parang suntok sa buwan na lang yun, no? Walang controlling, no? Lalo na kapag nag-stop ka ng system, no? Pag nag-stop ka ng system, so tuloy-tuloy lang siyang mag-drain hanggang sa mag-empty. Wala kang control. Paano kung naglagay ka dyan ng bathtub soap mo, no? Yung sabon, no? Di na wash out yun, no? Kung wala tayong control, no? So it's not a good system design nang wala tayong control. Okay? We really have to put control to our system. Okay? So this will be the block diagram of outlet water flow rate control. No? So once more, we have the water level, kung ano man yung initial water level natin, no? At start, i-determine yun ng ating system using the water sensor. And it will tell the PLC na, uy, ganito yung level niya. Kunwari, nasa 12 inches deep yung initial water level. So, si PLC naman, it will give a command to the drain valve to open further or to close further yung valve. Para kung pag open further, meaning lalakas yung flow rate. Pero kung bahagyang magsasara, so babagal yung flow rate. Okay? And of course, yung water inside the tub would be adjusted mula dun sa kung ano yung initial na nabasa. And yung output signal natin is the flow rate. Kasi yun nga yung ating kinokontrol dito. Yung flow rate ng drain water. Now, naisip nyo ba na as I discuss this, meron ba sa inyong nakapag-isip? Kunwari na sense ng sensor na 12 inches yung level ng water, ano ngayon? Paano yun malalaman ni PLC kung mataas ba yun? Or mababa ba yun? Kasi sabi natin, pag mataas ang water level or increasing yung water level, mag-i-increase din yung flow rate. So, kung ang binibigay ni sensor is 12 inches, how will the PLC know kung pataas ba or pababa ba? Okay? Now, note that the PLC could be programmed to determine if the reading from the sensor is increasing or decreasing. Yung ating water sensor, the ultrasonic water sensor, reads the actual water level at a time. Kung ang water level is nag-i-increase, okay, say from 12 inches, nag-increase siya to 13, nag-14, nag-15 inches, so patuloy niyang nababasa yun at patuloy din siyang magbibigay ng signal na nagbabago from 12 to 13 and so on. Now, ang PLC, programmable siya such that madidetermine niya, no, ang increasing value na yon. And that is an analog signal. Okay? Kasi ang binary signal, it's either high or low only. Walang in between. Okay? And then, it was required, no, that in our block diagram, we label the signal. So the signal from the water sensor is electrical signal. The signal coming out from the PLC is electrical signal. While in the drain valve, it's already a water flow. Ang signal na ibinibigay ng drain valve ay flow ng water na may certain flow rate. Okay? At yung water flow na yon nagpapatukoy sa dami ng tubig na nababawas sa ating bathtub. Okay? So it's important, class, no, to determine the type of signal, kung electrical signal po ba siya or hindi na. No, in every stage of the subsystem. Bakit importante yon? Para kapag kayo ay nagkumakabit din, no, ng block diagram, alam nyo kung ano yung proper connection. Okay? Yung bang hindi maging impossible, okay, kung na ikinabit. For example, just imagine this. Kung ang drain valve, ikabit mo, may arrow papunta sa PLC. Okay? Alam naman natin ang valve, ang inilalabas ng valve, water. Naglalabas ba ng electrical signal ang valve? Tumatanggap siya para ma-actuate siya. Pero naglalabas ba siya ng electrical signal? Hindi. Yung tinatanggap lang ng PLC, electrical signal lang. Ito, tubig. Kung lalagyan mo yan ng arrow papunta doon, baka nabasa ng tubig yung PLC, electronic yan, di sumabog. Diba? So it's very important that you know the type of signal, kung ano yung specifications din yan, no? Kung ano yung type ng signal nang pumapasok sa isang PLC at lumalabas. Actually, hindi lang electrical signal, aalamin nyo pa yan kung ano yung voltage rating niyan, ano yung current rating niyan, no? Para hindi siya masira. Ganon din sa mga sensors natin, ultrasonic, meron niyang, so anong input signal? Okay, the sound, no? The water level converted to sound. Okay, sound signal. Okay? Sige. So that's the block diagram for our outlet water flow rate. Let's now proceed to the system requirement 2, the inlet water flow rate control. Okay, so this time I included in the drawing the flow rate sensor for the inlet valve and the outlet, the flow rate sensor for the outlet or drain valve. Okay? Actually, kanina pa, mula sa umpisa, nakakabit naman ang mga yan. Okay? Hindi ko lang sila in-include sa slides kanina to emphasize na hindi naman sila pa kasama sa controlling ng drain valve flow rate, no? Kaya hindi ko sila in-include kanina. Okay? And then this blue line here indicates that there is water flowing sa flow rate sensor to the valve, no? May water na pumapasok at may water din na lumalabas. Ganun din dito, may water from the tub na lumalabas dito. Okay, at ganyan, no? So yun yung water. Now, itong mga lines na ito naman yung mga electrical wires, no? Electrical wire connection. Okay. So kanina, nag-end yung ating pag-analyze at pag-discuss ng ating system na kung saan yung water level ay nag-i-increase, nagdi-decrease until na-reach na natin yung point ng equilibrium. So, nag-i-equilibrium na siya kapag equal na ang flow rate dito at yung flow rate doon, na siyang dapat ma-sense ng ating system. Okay, so that's why this time we have here a connection from our flow rate sensor to our PLC. Okay, and another flow rate sensor sa drain naman to the PLC. Okay, so kung ano yung actual flow rate sa inlet at saka sa outlet ay naiko-compare dito sa PLC. Okay, at ano nga ang mangyayari? Ano nga ba ang requirement ng ating system? Kapag na-detect ng PLC na nag-equal na ang flow rate sa inlet at saka sa outlet, that is the time na pwede na tayong mag-adjust. Equilibrium state na yun. Okay? Now, I omitted here the ultrasonic sensor, the water level sensor. Actually, nandun lang naman yun sila. Hindi naman yun nawawala sa connection or sa installation. Tinanggal ko lang siya dito just to emphasize na hindi nakasama sa controlling ng flow rate sensing and the controlling of the flow rate of the input. No? Hindi nakasama yung water sensor. Okay? Para ma-emphasize lang. So, at the point na nag-equilibrium na, nag-steady na, or nag-constant na yung water level, what's next? Anong gusto nating ma-activate? Okay. So, gusto na nating makontrol ang flow rate dito. Okay? So, ang flow rate kasi, at the start, kanina, ano nga ba sabi natin? At the start, constant ang flow rate dito. Na-record niya, no? Mula kanina pa, na-record niya na. Okay? Nabibigay niya na kay PLC. Okay? So, ngayon na alam na ni PLC na nag-equal na silang dalawa, that's the time na ma-activate yung relay. Parang electronic switch. No? Parang, di ba, ang mechanical switch, pipindutin mo on, pipindutin mo off. So, magto-turn on ito, ang relay na ito, electronic switch, by the time na nag-equal na yung flow rate. At kapag nag-on na ito, that's the time na meron ng connection. No? So kanina, di ba, wala. Ngayon, nilagyan ko na to indicate that activated na, no? Energized na ang inlet valve para mabago ang flow rate sa kanya. So paano again mababago? Nabanggit natin kanina na kapag 80%, 100% open ang valve na ito, mas lalakas ang flow rate. Pero kung 10% to 20% open lang ito, bahagyang nakasara, so mabagal ang flow rate. So na-activate na siya dahil na-turn on na yung switch. Okay? So, please take note also that in our assumption kanina, no, the pressure of the supply water affects the flow rate of the inlet water. And that is a disturbance. Sabi natin, nakukontrol natin ang flow rate by adjusting the percent opening nitong inlet valve. Okay, so nababago natin yung flow rate. But take note that aside from the setting of the opening, kusang nagbabago rin ang flow rate ayon sa pressure ng supply water. Pero sa assumption natin kanina, nag-assume na tayo na hindi ito nagbabago dahil that changes is a disturbance. But the system can be designed to automatically correct the effect of the disturbance. But you're going to do that after you have completed the design without the disturbance first. Okay? So, to continue, here will be the block diagram for inlet water flow rate control. So, as we've discussed, we have the inlet flow rate sensor to determine the flow rate of the supply water. And we have the outlet flow rate sensor to determine the outlet water flow rate. So these two signals will be compared in the PLC. So yung PLC, meron na rin itong function sa loob na parang comparator. Okay, parang differential amplifier, parang ganun. To compare two signals. At kung ano man yung comparison, either positive error or negative error, okay, it will trigger the relay. Okay, once the relay is triggered, then the inlet water assembly will be activated. So ano bang inlet water assembly? Ito yung nandun yung inlet valve, no? Yung fill valve at saka yung next slides natin, no? Makikita nyo kung anong kabuuan ng inlet water assembly. And of course, ang kinukontrol natin ay yung inlet water flow rate. Okay? Kaya ito naka-light gray to emphasize that kahit na wala ng relay dito, no, kahit direkta na from PLC to this, no, nilalagyan ko lang to emphasize that there is a relay or an electronic switching action. Okay? Kasi ang relay na ito, nasa loob na siya ng PLC. But if you're using microcontroller, then you need a PLC here. And determining the signals, of course, by now siguro hindi na kayo nalilito, no? Ang sensor natin, transducer yan, it converts flow rate signal into electrical signal. Ganon din dito, flow rate signal to electrical. Ang output ng PLC, of course, electrical signal. Ang output ng relay is electrical signal. Okay, in this case. Okay, kasi may mga relay din na mechanical, no? Ang mechanical ang action niya. But in this case, this is electrical ang signal if you feed dito. Okay? So that is our block diagram. Of course, the water flow in the output. So our last requirement, the water level control. So for the last requirement, okay, so yun na nga, no? There is already a connection from the PLC to our fill valve. And the next thing that we want to do is to input a water level na gusto natin. So dito na tayo magsiset ng reference value or set point ng water level na gusto natin. I just want to reiterate again, at this point, bago natin pihitin yan, naka-equilibrium na to. Para bang constant na siya. Equal na ang flow rate dito at saka dito. Kaya nagme-maintain na siya into a certain height. Pero yung height na yan, hindi yan yung desired natin kunwari. No? So, kung gusto nating i-adjust, pipihitin natin ito. Okay? So, kunwari, if we're going to rotate clockwise, the water will go up. And when it go up, ano nga ba yung specification kanina? Ibig sabihin, the flow rate is higher. But when we're going to rotate it counterclockwise, then the water level goes down, meaning to say the flow rate here is decreasing. Okay? So that will be the scenario. And once more, binalik ko na yung ating water level sensor kasi this time, kailangan na natin siya. Okay? Kasi, syempre, as you adjusted here, no, inilagay mo na siya sa kung saang setting gusto mo. Okay? Then, for example, nag-rotate tayo clockwise. So, the level will be increasing. The flow rate increased. And so, the water sensor here will detect kung nag-increase nga ba. At yung pag-increase niya, it is reading the exact level. At ibabato niya yun kay PLC. At si PLC, i-compare ni PLC sa naka-set na input na desired. Kasi by the time na nag-equal na, that's the time naman na i-stop niya na ito. actually hindi totally mag-stop. Hindi titigil yung input ng water. Pero ang nag-i-stop dito ay yung adjustment ng opening or closing niya. Kasi kanina, by the time na pumihit ka dito, clockwise, ibig sabihin, pumipihit din sa loob nito, pumipihit din pabukas ng pabukas. So, titigil na yon yung pagpipihit sa loob ng valve pabukas kapag nag-equal na yung reading nito sa nakaset dito. Okay? So, this will be the block diagram. So, ito yung ating water level setting. Of course, we need a potentiometer for that kasi mechanical action yun, yung pag-rotate. So, from mechanical to electrical, and then we have the PLC, and the PLC will command the fill valve. Okay, na-activated na through the relay. No? Hindi na natin in-include dito yung relay. Understood na yun. Okay? And ang fill valve naman, activated na. So, may water flowing na siya na increased flow rate na. At yung water na sinusupply ni fill valve ay matatanggap ni bathtub. At yung tubig kay bathtub ay magkakaroon ng increase in the water level kung nag-increase tayo ng setting. So, yung actual water level na nag-i-increase, isi-sense niya ni water sensor, babasahin niya at ibabato niya kay PLC kung ano yung actual water level. At i-compare ni PLC doon sa input na, reference input na inilagay ng user. So, kapag nag-equal, not equilibrium, kundi na-reach na yung enough water level. Again, I want you to picture out, no? Di ba meron tayong transient response, steady state response. Okay, dahil water level ito, so pagkapihit ng knob, magte-take action. So imagine nyo na nasa transient response siya, yung curve na paakyat. Okay? And by the time na-reach niya na yung kanyang desired water level, almost nag-equal na itong dalawang signal dito, then mapupunta niya siya sa steady state value niya. But again, hindi yun smooth na nag-steady state agad. Maaring mag-oscillate ito up and down bago mag-steady. Okay? So, yun yung makikita natin, no, sa MATLAB natin, no, yung mga example na nag-oscillate yung mga system. Okay? So, once more, the signals are electrical signals. By this time, siguro, talagang gets nyo na kung kailan electrical ang signal, kailan hindi electrical ang signal. As I've said, it's very important. So, the last part, pagsasamahin na natin ngayon, no, o the overall schematic and block diagram. So, eto na siya, no, yung kabuoang schematic diagram natin. Hindi ko na in-include yung relay, of course, it's understood already. No? So, for discussion purposes kanina, na-indicate lamang natin. And for our block diagram, so, eto na yun, yung tatlo, no, pinagsama-sama na. When you are doing your drawings, actually, kahit ako, scratch paper muna yan. Kasi gulo-gulo muna yan. At habang fina-finalize natin, syempre, pinag-iisipan din natin yan, how are we going to integrate the three different block diagrams into one na convenient ang itsura at walang nag-i-interconnect yung walang nagko-cross na mga lines. And kagaya nito, isang PLC na lang, hindi yung hiwa-hiwalay pa sila ng PLC. Kasi kung hiwa-hiwalay, so may implication na sa actual, parang nagkaroon ka ng tatlong PLC, but in reality, isa lang naman. Kagaya rin dito, pinag-isa ko na yung bathtub kasi kung isang block ng bathtub dito, isang block ng bathtub dito, parang nag-i-indicate siya na ang actual mo, dalawa yung bathtub mo, which is not, no? So, talagang pinag-aaralan ito, no? at pinag-iisipan ito kung paano ito i-draw ng presentable. Okay? And dito naman, once more, naka-gray siya, pero we could omit that relay. And ganyan na yung ating final block diagram. Okay? So I hope that's very clear. If you have questions, you might put a comment or chat sa ating chat box dito sa lesson na ito so that we could clarify kung ano pa yung mga questions nyo with this problem. Or you might ask for an online meeting, no? Instead of chat, no? Kung gusto nyo online meeting, pwede rin naman. And I hope you will be inspired once more. Proper practice with diligence and interest makes learning perfect and fun. Okay? Good day, students, and have a nice day.